Hello and welcome to Algebra 2, Chapter 9.3, and today we're discussing graphing general rational functions. Previously we graphed simple rational functions, and this is just going to be a continuation from that. Alright, so first of all, remember that a rational function is one that looks like a fraction, and so this might look a little daunting, but all this top thing is saying, f of x is our function, and so p of x and q of x both need to be polynomials. And so what you see here is just the basis of a polynomial. So that's going to be one polynomial down here. We have b's representing another polynomial. So this is just the largest degreed, so we're descending order, and a sub m is just its coefficient, and then you're just working your way down to this last number, which is going to be your constant. So same thing, top and bottom there. But three really important things that we're going to learn from this. The X-Intercepts, if there are any, that they are going to be the real zeros of p of x, which is the top. Okay, so if this crosses the x-axis, and that would be when y is 0, then these are going to be the zeros of the top, because that's going to be 0 divided by something is always 0. Okay, so the zeros of the top are going to give us the x-intercepts. The vertical asymptotes are the zeros of the bottom part. So that's when it's going to be undefined. Those are your vertical asymptotes. And then if we have horizontal asymptotes, well, it says the graph of f has at most one horizontal asymptote, and depending on the degree of the top and the bottom, so m is the degree of the top, n is the degree of the bottom. If m is less than n, then our horizontal asymptote is at y equals 0. If m equals n, our horizontal asymptote is at y equals the coefficient of the top, leading coefficient of the top over the leading coefficient of the bottom. And if m is greater than n, then there is no horizontal asymptote, but we can use this as the end behavior of our graph here. So make sure you've taken note of all that, and I have a few examples for us to try. Okay, so y equals x squared over x squared minus 1. So going down the list that we just wrote down, if we want to check for x-intercepts, x-intercepts are where the top equals 0. So if I set the top equal to 0 and you would square root both sides, we are going to have an x-intercept at 0. So that's going to happen to be one of our points on our graph. Okay. So what about our asymptotes? So first it mentioned vertical asymptotes. And this was where the bottom was equal to 0. So we're just going to take the bottom, set it equal to 0, add 1 to both sides, square root, and then remember that we add a plus or minus. So we have two vertical asymptotes. We have a vertical asymptote at positive 1, and we have a vertical asymptote at negative 1. What that means is our graph is actually going to have three parts, because you have to have a part left of that, between those, and then to the right. So we have a three-part graph. And let's go ahead and look real quick at our horizontal asymptote. And remember, for our horizontal asymptote, we're going to look at our degrees of the top and the bottom. So the top degree is 2, bottom degree is 2. So if you're looking at those bullets that you wrote down, it's the second one. If m equals n, then our horizontal asymptote is at y equals, and it is the leading coefficient of the top, which is 1, over the leading coefficient of the bottom, which is 1. So we have a horizontal asymptote at 1. You know, you probably can't see that very well. Let me come in and make it blue. Alright. So from here you're going to use a table. And so we would really need to make 3 tables. So maybe we'll just start on the left. That makes most sense. So This is going to be the left over here. This is going to be my table for the left. And so I can't use -1, so let's go to -1.5. And I'm going to plug it into my function up here. And -1.5 gives me a positive 1.8. So about there. Alright, and then let's go to -2. And -2 gives me 1 1/3. So we're getting close to that asymptote. Let's try -3. -3 gives me 1 1/8. So even closer to that asymptote. Alright, so this one up here comes in and up like that. So next let's look at our middle one, which we already have 1.4 because that's where our x-intercept was. So I already know 0, 0 is a point. So if we do, let's try 0.5, we get -1/3. And at -0.5, we also get -1/3. And what we're looking at here is one that comes up almost like a quadratic right in there. And our last one over here, we're going to call this one the right-hand side. And we can't do 1, so let's start with 1 1/2. And that actually ends up being 1.8. And if we go to 2, we get 1 1/3. So we're kind of copying what we were on the other side. Won't always be the case, but it is in this one. And so this side comes down. Oop, and you should probably hit your points. See if I can try that one more time. Okay, so I'm not very good at hitting the points. There we go. So that's our graph. If it did ask for domain and range, domain is going to be all real numbers except, what x's can we not have? 1 and -1. And range is going to be all real numbers except 1. Alright, I know the example takes a long time, but I think we should look at a few just to make sure we know how to do them. So this one, we'll start the same way. We're going to start with our x-intercept, and so the x-intercept is the real zeros of the top. Well, the top is -1, and you're going to set -1 equal to 0, and that's not going to mean anything. So there are going to be no x-intercepts. And then if we look at our vertical asymptote, that's when we set the bottom equal to 0. So we get x cubed equals -1, and we're going to cube root both sides. X equals -1. So we have a vertical asymptote at -1. And then our horizontal asymptote, we look at our degrees of the top and bottom. And the degree of the top is 0. So it would be less than the degree of the bottom. And if you have that table handy, degree of the top less than the degree of the bottom, that's the first one, which means that y equals 0 is an asymptote. So that would be our x-axis here. Alright, so this time we just have two places. We'll call them L and R for left and right. And then from there you just make your table. So once you have set up where your asymptotes are, so to the left, if we did -1.5, we're at 0.42105, and you might check these. I worked them out ahead of time, but you never know. So this one on this side looks pretty typical to what we've had before. I know you're looking at these numbers going, these aren't typical, but 9.2. So comes down there, comes up here. So this one does come along here and up. But I want to point out something on the other one. And this is not going to be something you technically know ahead of time. So I'm going to start at 0. Yeah, negative 1. 1 is negative a half. 2 is negative a ninth. Negative 1/2 is negative 1.143. Oh, the cat woke up. So sorry. Alright, so at 0 we're at negative 1. At 1 we're at negative a half, negative a ninth. You know, that all looks typical, but if we come the other way, what you're going to see in here is that there's a little bit of a jog. And it doesn't go down as far as we think it should. And so it comes in, does this little jog, and then goes down. And that is something that you find just by trying more points. Okay, they don't all have this nice curve like the top one on the left does. Sometimes they have this little jog in them. Alright, so domain, we're talking all real numbers except negative 1. And range is going to be all real numbers except 0. And I got one more for us to look at. Alright, so our last one, I wanted to try one with a little more of a trinomial on top here. So you're going to do it the same way, okay? X-intercepts, you are finding the zeros of the top. So we're going to set the top equal to 0, and this factors, which you just need one of those. So if x minus 1 is 0, x equals 1 is a x-intercept. So we'll plot that point. And then we have our, what do we do next? Horizontal asymptote? Nope, we do vertical asymptote. It's been so long since the last example, I've forgotten. Alright, so vertical asymptote is we set the bottom equal to 0, because that's when it's undefined. So we got 1 at 2 here. And then horizontal asymptote is where we look at our degrees. Okay, so this time the top degree is greater than the bottom degree. So if we look at our chart, our table we did to begin with, if m is greater than n, the graph has no horizontal asymptotes. Okay. But it does talk about the graph's end behavior. The end behavior is the same as the graph. So just make us a little note here. End behavior. Y equals, and then it says A sub m over B sub n, which is our asymptotes, or not our asymptotes, leading coefficients. So many words. All right. Both 1. X to the m minus n, which is going to be 2 minus 1. So this just really becomes x. So our end behavior is the same as the line y equals x. So I'm just going to kind of, this is the line y equals x. So our end behavior is going to go in that same direction. So this one up here is going to go up, and this one over here will go down. And so the question now is just kind of a little more, where is that? So you don't necessarily have to draw that line. If you really just look at it and go, hey, it's a line with positive slope, you know what happens to it. So let's make a table. And again, I would do the left-hand side of that asymptote, and I would do the right-hand side. So if we start with the left-hand side, we already have that at 1, it's at 0. So let's do 1.5. It's negative a half. 0 is also negative a half. Negative 1 is negative 1 1/3. Negative 2 is negative 2 1/4. And so what does that look like? 1 1/2 is negative a half. 0 is negative a half. 1 is negative 1 1/3. 2 is negative 2 1/4. What this is going to look like is this is going to come up this asymptote here, turn, and go down that way. And that's that end behavior looking like that line we just talked about. On the right-hand side, we start with 3. 3 is at 4. 4 is at 4 1/2. 5 is at 5 1/3. And we probably need to sneak in here a 2 1/2. 2 1/2 is at 4 1/2. So at 2 1/2, 1, 2, 3, we're at 4 1/2. Then we go down to 4 and go back up to 4 1/2. So we're doing that same thing over here as it's coming down this side, up and out. Alright, and if you were going to do domain and range, domain is going to be all real numbers except 2, and range is going to be all real numbers. Nope, just all real numbers. There's no exception because there was no horizontal asymptote. Alright, that's the bulk of 9.3. We'll look at the rest of those examples in the word problem in class. If you have any questions, let me know. If not, I will see you in class next time. Have a good day.